Can you boil water with ice? This weird physics experiment will blow your mind. Have you ever seen someone boil water using ice cubes? Sounds completely backward, doesn't it? Boiling water with heat makes sense but ice. Well, in today's experiment, we're going to show you how you can actually make water boil at room temperature using ice. Yep, you heard that right, and it all comes down to the fascinating world of air pressure and vacuum physics. Hey everyone, welcome back to the channel where we turn simple household items into mind-blowing science lessons. Today, we're redoing one of the coolest physics experiments that plays with your expectations. It reveals the power of pressure. Let's dive in. First, here's what you'll need. A heat-resistant glass, or beaker, with some water, a metal tray, or shallow dish, a small block of ice, a microwave, or stove to heat water, a pair of tongs, or gloves, a transparent plastic dome, or large glass jar. Optional thermometer. This experiment is all about showing how boiling isn't just about heat, it's about pressure too. And that's a key idea in science learning. Alright, let's set the stage. Step 1. Heat some water in your beaker or glass. You want it hot, but not actively boiling. Around 70 to 80 degrees Celsius is perfect. Once the water is heated, carefully place the beaker onto your metal tray. Now here's the twist: take your large dome or jar and carefully invert it over the beaker, trapping the air inside. You've now created a sealed environment around your warm water. At this point, the water looks completely calm. Nothing unusual. Now, place a few pieces of ice on top of the dome or jar. If you're using a plastic cover, make sure it can handle the chill. You're not cooling the water directly, you're cooling the air inside the dome. Watch closely. After a few moments, you'll notice something surprising. Tiny bubbles start forming at the bottom of the water. Then more and more. And suddenly it's boiling. But wait, we didn't add any more heat. In fact, we just added ice. So what's happening here? Let's talk science. Boiling occurs when the vapor pressure of a liquid equals the surrounding air pressure. Usually, we increase the water's temperature to raise its vapor pressure until it matches atmospheric pressure. That's when we see boiling. But there's another way. If we lower the surrounding air pressure without changing the water's temperature, we can also reach that boiling point. And that's exactly what's happening here. When you cool the air inside the sealed dome with ice, the air molecules inside start moving more slowly, reducing pressure. This creates a kind of mini vacuum inside the dome. With lower pressure above the water doesn't need to be super hot to boil. It starts boiling at the lower pressure even at temperatures where you'd normally touch it without a problem. Isn't that amazing? This simple experiment demonstrates several important physics ideas. How boiling point changes with pressure. The concept of vapor pressure, real world uses of pressure in science and technology, for example. This is exactly how pressure cookers work, but in reverse. They increase pressure to raise the boiling point, so food cooks faster. Meanwhile, in high-altitude places, water boils at lower temperatures. Because the air pressure is lower, so cooking takes longer. And in science labs, we use vacuum chambers to boil liquids at very low temperatures. Sometimes, even below room temperature. That's how scientists study the behavior of materials in space-like conditions. Here's something extra to try. What happens if you do this experiment with warm but not hot water, or with a larger dome? Or if you try to increase the air pressure instead of reducing it? Let us know your results in the comments. Sweet. Love to hear how your version turned out. So what have we learned? Boiling isn't just about heat, pressure matters too. You can use cold to make something boil. Air pressure is all around us and it's doing more than we realize. This experiment is simple, safe, and seriously fascinating. It's perfect for classrooms, science, fairs, or just impressing your friends and family at home. If you enjoyed today's experiment and learned something new, hit that like button and subscribe for more cool hands-on science like this. And remember, everyday objects can unlock the secrets of the universe if you just look at them through the eyes of curiosity. Until next time, keep questioning, keep testing, and always keep exploring. Because science isn't just a subject, it's a way of seeing the world.